will solve the 22nd question first.
Yes, sir.
Okay. So, we have two plates. We have an electron. It is projected horizontally with the speed u.
Yes, sir.
The best part about two dimension is 2D is that we can solve it as two 1Ds. Okay. Meaning that I can make 2D into x-axis, y-axis and deal independently.
Yes, sir.
He is showing that the electron is basically going this way. That means initial velocity in this direction is 0. But still, if it is going in that direction, that means there is an acceleration in that direction. Okay.
Yes, sir.
Now, what I mean by two 1Ds is I am going to write equations in the along the x-axis and along y-axis individually.
Yes, sir.
So first, if we are solving a kinematics problem initially, so how do we solve it? Let us take all the given inputs. Right now, we are not going into what the acceleration is. We will say the acceleration in the y direction is ay. Okay.
Yes, sir.
So what are the inputs? Ux is some u, initial velocity in the x direction. Initial velocity in the y direction is 0. Acceleration in the x direction is 0 because there is nothing to accelerate. And acceleration in the y direction, let us take it as a. Okay.
Yes, sir.
So my equations, because now distance is also involved, so my equations eventually will come out as Sx is equal to uxt plus half axt square and sy is equal to u by t plus half ay t square. Okay.
That term will be 0 and we can put time here.
So in these two equations, the new thing that I brought in is time basically. Since particle is a single particle and its journey is happening in this way, although we are writing its kinematic equations along x-axis, y-axis separately, the particle itself is a single particle, so it is not going to have x displacement separately, y displacement separately. The equations do not literally mean that the particle is going along x-axis, then going along y-axis. That's not the story. We are writing the equations along x-axis and y-axis separately, but the particle originally is the same particle. That means if 1 meter it went along x-axis and let's say in the same time it went half meter, so for 1 meter and half meter the time is basically the same. Are you getting my point?
Yes, sir.
One important point that usually we mention it in kinematics is how am I able to write the horizontal and vertical equations independently? Because the effect of any vector in its perpendicular direction is 0. So because the effect of anything along x-axis is 0 along y-axis and vice versa, I can write the equations of x-axis and y-axis independently. Are you getting my point?
Yes, sir.
Okay. But particle is a Same particle, irrespective of where the particle is through the journey. Particle is only one particle. So if in a given time t, if it is here, we are writing the equation Sx in terms of t and Sy in terms of t.
Yes, sir.
Okay. Now
Yes.
moving ahead, what is acceleration? This acceleration is due to the electric field. Therefore, my acceleration is equal to
E by M.
force divided by mass. Force is nothing but charge into electric field divided by mass. Now, E by M, what is electric field between the plates? Sigma by epsilon naught. E by M into sigma, what is sigma charge divided by area?
U upon. Sir, over here we have to take the electric field of the plates.
Electric field due to the plates between the plates, due to the charges on the plates between the plates.
Like we have to take the effect on the electron.
Yes.
Yes.
What on it? What? See, I'm coming to that. The acceleration I'm taking in the upward direction, because in the question he has shown me the direction of motion upwards. That means the force on the electron is in the upward direction.
Yes, sir.
But force is nothing but charge into electric field. So my electric field should be in the downward direction.
Yes, sir.
Because my F bar is equal to minus E times E bar. Because charge of the electron is negative.
Like the force acting on the electron.
The force, direction of force and direction of electric field are opposite to each other because the charge of an electron is negative.
Yes, sir.
This minus sign makes the direction of force and the direction of field opposite to each other.
And that field is due to those plates. That's why we write the electric field as sigma by epsilon.
Field is due to the plates of the capacitor, but right now I am at the direction of the field.
That I understood.
Is in the downward direction. If the direction of the field is in downward direction, that tells me that I can take the positive charges on the plate as up and negative charges on the plate as the bottom plate.
Yes, sir.
Okay. And now the charge that is there on the plate, I am taking it as plus Q and minus Q.
Yes, sir.
In this situation, the magnitude of electric field due to this plus Q and minus Q is going to be Q by A epsilon naught because it is sigma by epsilon naught.
Yes, sir.
The acceleration is force upon mass. Force is charge into electric field upon mass. Electric field is Q by A. Okay.
Yes, sir.
Also, in the original equations, my Ux is basically Uy is basically 0 and my Ax is basically 0. So my Sx will become Ux into T and my Sy will become half A by T square. And that Ay is nothing but this A only.
Yes, sir.
Clear?
Yes, sir.
The time is basically same. So eliminating time, we can square and divide. Now what is he asking? The separation between the plates of the
Initial
capacitor.
velocity.
Hmm.
So that the electron doesn't collide the plates.
What should be the initial velocity so that the electron does not collide? That means this the time taken for the electron to displace from along x-axis from leftmost end to the rightmost end should be the same time taken for the electron to displace from bottom end to the topmost end. That is the condition. Okay. Now, what happens if it displaces between the plates faster than the horizontal thing? It will hit the plate here somewhere.
Can that also happen?
It will hit somewhere, right? I mean, depending on what the acceleration values are, initial velocity.
Well, how can two time intervals act as at the same time?
No. The particle is moving along this trajectory, right?
Yes, sir.
Instead of this trajectory, the particle can move along this trajectory and hit the plate.
Yes, sir.
Or the particle can leave something like this.
Yes, sir.
When I am saying that in the same given time t, the horizontal displacement is from left end to right end. The vertical displacement is from the bottom end to the top end. It gives me exactly this condition. So what he is mentioning in question is that it just doesn't hit, will basically be this condition. If suppose I will say that the particle is displacing along y-axis before displacing completely along x-axis, it will hit the wall of the plate.
Yes, sir.
If it displaces along x-axis before it displaces along y-axis completely, then it goes away in this third path. Only in the situation that the particle just hits or just doesn't hit, in that condition I can say that
Whether displacement should be same.
in the same given time. Okay.
Yes, sir.
Fine. Now, the distances between the now our kinematic story, all that has come to a certain level. Now we have to focus on the capacitor story part of it. Both the capacitors are made of square plates of edge A. What he is trying to say is my Sx is nothing but A. Okay. So instead of taking this as A, because he has given the side as A, let's not confuse. Let's keep the acceleration as Ay only. Okay. My Sx will become what? A.
Yes, sir.
What is Sy? D1.
Yes, sir.
Okay. So Sy is D1. Now, the separation between the plates of capacitors are D1 and D2 as shown in the figure. A potential V is applied between the terminals A and B.
Yes, sir.
There are two capacitors. Both the capacitors are in series. So charge is same. So V is Q is equal to CV. So V is inversely proportional to C. Correct?
Yes, sir.
C, because the combination is series, therefore charge is constant. Q is equal to CV implies that C into V is constant. That means the potential difference across each of the capacitor is inversely proportional to the capacitance.
Yes, sir.
But I am not stopping over here. My capacitance for a square plate is epsilon naught A by D.
Yes, sir. That is for a parallel plate.
These are also parallel plate capacitors.
Yes, sir.
Capacitance is epsilon naught A by D. What I am trying to look at over here is epsilon naught and area for both the plates are same. Therefore, I am saying my capacitance is inversely proportional to 1 by D. Inversely proportional to
Yes,
D,
sir.
right? So this means my capacitance is inversely proportional. So my voltage is proportional to D.
Yes, sir.
This is how the series and parallel thing that I told you, right, is
Yes.
mostly valuable. That means my V1 is to V2 is D1 is to D2.
Yes, sir.
I am interested in V1 because electron is jumping around, playing around in D1.
Mm.
Correct? That means from this information, what will I get my V1 as? D1 by D1 plus D2 into V. Is this clear?
Yes, sir.
It might look that I am going slow, but actually using these things I am going very fast. If I solve the same things in a layman way, code will be filled easily. This is in series, this is in series, take the charge is Q, capacitance is C1, C2, capacitance is A epsilon naught by D1, A epsilon naught by D2. Because it is in series, 1 by C equivalent, very long, boring. Simply by capacitance inversely proportional to D, I can say capacitance proportional to D. Basically, I want to get V1 because I want to get Q1. If I take this as Q1, I am interested in Q1. Are you getting my point?
Yes, sir.
What is Q1? Q1 is C1 into V1, correct?
Yes, sir.
Q1 or Q, well, because it's in series, we can write it as Q only. That's not a thing. A epsilon naught by D1, right? I'll make
Yes.
it Q because why confuse? It's in series. Q is anyway same.
Mm.
Okay, so let it be Q only instead of confusing ourselves. Q is C1 into V1.
Yes, sir.
A epsilon naught by D1 capacitance into V1 is D1 upon D1 plus D2 into V. See, my D1 and D1 is getting cancelled. My answer is A epsilon naught by D1 plus D2 into V.
Yes, sir. Sir, why those equations, sir?
Huh?
Why those equations?
Which equation?
Not those kinematics thing.
We are coming there. Is this fine?
Yes, sir.
I got charge. Why did I get charge? So that I can get this fellow, acceleration. What is acceleration? E by m into Q by A epsilon naught is V by
Yes.
D1 plus D2. Q by, from this information, I got Q by A epsilon naught is V by D1 plus D2. Is this clear?
Yes, sir.
Okay. My entire story it lies in for the same time t. Time
Sir,
is same.
sir, how did you get that idea?
Get what?
Because there is Q by epsilon naught, so you found Q.
No, get what? How did I get what?
There is that idea to find Q. There is Q, that's all.
Because I got here Q, right?
Like everything else is like we know only QS and then that's it.
Yeah.
Yes, sir.
Okay. Next, I am saying the important thing in this entire story. My problem I am solving on the basis that time is same. There is one cricket ball. Cricket ball I threw, projectile. It's going like this. So at any point, I will find horizontal displacement, vertical displacement. I am finding horizontal and vertical displacements, but the ball is the same, right? It's one single object.
Yes, sir.
The time taken by the ball to go from here to here is same, and at the same time I'm using in the x-axis equations and y-axis equations. That's the basis that on which I am solving this question. So t is basically same.
Yes, sir.
Okay, especially I am mentioning because not necessarily t is same. Sometimes in the question in kinematics, I can give the question in a way, not for single ball. If you have single particle, then obviously t has to be same irrespective of where it goes. But suppose I have two different particles, then I can say that you must have seen questions where I threw one particle. After 5 seconds, I threw another particle. Here, time is not
Yes,
same.
sir.
Right? For both the ball, no, for both the particles, my time is not same. In this situation, it's one single particle. Therefore, my time is same. So,
Yes, sir.
and I'm not interested in time actually. I am interested in v, right? In u, with what minimum speed should the electron be projected? I'm interested in u.
We can square that and
I'm interested in ux. We can square and divide these equations, right? So if I square and divide, I'm directly writing a square divided by, see, I'm writing sx square basically, divided by d1 square is equal to ux square. Oh, by the way, I don't have to divide it by d1 square. I have
yes,
to
sir.
divide by d1. Square the sx and divide it. That's it, right? So a square by d1 is equal to ux square divided by half half ay.
Yes, sir.
He has given the initial, that only we have to find. Initial velocity. Ux is what we have to find, right?
Yes, sir.
Now, my ux is equal to under root of a square by d1 into ay by 2, correct?
Yes, sir.
Ay is this story.
Yes, sir.
So I'll put it in brackets, a square by d1 into ay is this fellow. E by, I am writing 2n because there is 2 here, into v by d1 plus d2 whole to the power 1 by 2. Is this
Yes.
visible?
Yes, sir.
I got the answer. What should be the minimum speed? My minimum speed should be under root of a square by d1 into e by 2n into v by d1 plus d2. That's it. Okay.
Yes, sir. Sir, I'm writing in the book like where we.
No. Take a snapshot. I'll tell you.
Yes, sir.
I am recording. Am I recording? Yeah, I am recording. Virginie. I'll post it on because anyways today you don't have anything to do with capacitors. Take the screenshot.
I took it, sir.
Let's move to 24 is done.
Yes, sir.
Okay. What is 23? The plates of a capacitor are 2 centimeter apart. An electron-proton pair is released, and it is found that proton reaches the negative plate at the same time as the electron reaches the positive plate. At what distance from the negative plate was the pair released? Did you read the 23rd question?
Sir,
Hmm.
can you just find the field between them?
But
When we are telling it's nothing but the distance between two capacitor plates.
So what is the story he's saying? He's saying at some place electron and proton simultaneously are released, correct? And it is observed that the electron and proton are reaching the opposite plates at the same time.
Yes, sir.
Both electron and proton are reaching at the same time. From this information, what information can I figure out?
The displacement is same.
He said same time.
Yes, sir.
So if same time is mentioned, I will draw. I have a capacitor. Somewhere over here, I have released an electron and a proton. I should not write E plus, but whatever. Let us just show it as negative charge and a positive charge. I have released from this point.
Yes, sir.
He is saying both are reaching the plates at the same time. What is the fundamental thing that generates motion in terms of kinematics?
Sir, can we tell acceleration is same?
Good. So if I am saying that I am reaching in same time, okay, I have to let me find out if the acceleration is same. Let me
Yes.
find out if the acceleration is same. The acceleration of the positive fellow is whatever is the force on the positive fellow divided by mass of proton.
Yes, sir.
Acceleration on the negative fellow is force on the negative fellow divided by mass of electron.
Yes, sir.
Correct? So I still don't know what I am talking. He said same time. I did not have any clue. I started to think what is the basic physical quantity which generates the entire kinematic motion is acceleration. Acceleration generates velocity, velocity generates displacement. So that's why I came to acceleration. And now I'm trying to figure out. I don't know where I'm going. Okay. Acceleration on the positive charge is basically force on the positive charge divided by the mass of the positive charge, which is proton. Acceleration on the negative charge is force on the negative charge divided by mass of the electron. Clear?
Yes.
Now, let us say there is some electric field like this. Electric field for both proton and electron is the same, right? Electric field is because of the plates of the capacitor. Electric field
Yes, sir.
is not because of if I'm playing with a negative or a positive charge. Electric field is because of the charges on the plates of the capacitor. Q, sigma by epsilon naught.
And if the time is not same, also acceleration will be same.
I don't know yet. And like I said, I don't know where I'm going. I'm just doing something just because I can speak something about physics. I'm just speaking. I don't know where I'm going. Electric field for both electron and proton is independent of them, right? Because electric field is due to the charges on the plates of the capacitor, Q by A epsilon naught, sigma by epsilon naught. Is this clear?
Yes, sir.
Why I am mentioning is because when I now further substitute forces charge into electric field, right?
Yes, sir.
For both proton and electron, my charge is anyways E. Therefore, I will get this like this, correct?
Yes, sir.
See, like you just now said, is the acceleration or the accelerations are going to be the same. Acceleration of proton, acceleration of electron.
One will
The
be positive, one will be negative.
forces are same because the charge on electron and proton is the same.
Yes, sir. Force, sir.
Forces are same, but force divided by mass is the acceleration. Mass of
Yes.
proton and electron are different.
Yes, sir.
Therefore, my accelerations are different. It is taking equal time to reach the plates, but accelerations are different. Initial velocity is 0.
Yes, sir.
So let my displacement of electron be SE and displacement of proton be SP.
Sir, the acceleration of electron will be negative.
But I am talking only in terms of scalar magnitudes, not in terms of vector. When I show the direction, then I will use minus sign.
Yes, sir.
Right now, I am only looking at the magnitude part of it, so I'm really not bothered about minus signs. Right?
Yes, sir.
Now, next thing is, he is saying at what distances from the negative plate was the pair released if both are moving at the same time. Okay?
Yes, sir.
That means the negative plate is here. That means he is asking SP. Also, my SE plus SP is 2 centimeter. Distance between the plates is 2 centimeters. So
Yes, sir.
now moving ahead, what is my SE? My SE is nothing but S is equal to ut plus half at square. Initial velocity for both the particles is 0. So I will directly write half acceleration of E into t square.
Yes, sir.
Similarly, half acceleration of P into t square. My t is the same.
Hmm.
Therefore, I can say
And equate it.
that.
And substitute it.
Therefore, I can say my T is the same. So, from this information, I can say my SE divided by AE is SP divided by AP.
Yes, sir.
But anyways, my accelerations have same forces in the numerator, masses in the denominator. So, can I write SE into mass of electron is SP into mass of proton?
Yes, sir.
Now, I want SP. So let me eliminate SE. SE is mass of proton divided by mass of electron into SP. I'll substitute this fellow over there. Okay.
Yes, sir.
So my SP, if I'll take it common after substitution, I will get mass of proton by mass of electron plus 1 is equal to 2 centimeter.
You get SP.
So the
yes.
distance from the, this is in terms of centimeter by the way, divided by MP plus ME. Is this clear?
Yes, sir.
Wait, let me erase this one and write the question number. Did you create a folder?
No, sir, I have to do it.
Like I said, it's better to create a folder. So this is 23. Why I did this entire thing is specifically to tell you that the kinematics is different and the dynamics is different. Kinematics is acceleration, dynamics is force, and these two are interrelated with mass. So if I am talking of, for example, he said same time. So I know I am talking of kinematics. Now when I am talking of kinematics, I have to ensure if my masses are same or not. Although this is a little bit confusing the way it is presented. It looks like it's confusing. Although in kinematics it is not dependent on masses. Then I got displacement in terms of mass only. Something mass, right? Although kinematics of a particle is not dependent on mass. Here, then why am I getting in terms of mass? Because my kinematics is and dynamics are related by mass, and my dynamic is the same. Or I know what the dynamics is over here. In this situation where my electron, proton, whichever charge it is, in this situation when I have a charge between the plates, the forces experienced by the charge is what is the known information for me. From the force, if I want to come to acceleration, I have to come across mass. Therefore, I have to take these equations under consideration and not go straight forward like you were saying, because it is same time, acceleration should also be same, and therefore then it implies that 1 is to 1, right? SE and SP are 1 is to 1. Then the answer will be 1 centimeter. But no, when I am coming from dynamics, that is force, to acceleration, I have to check if my mass is same. Suppose in situations where my mass is also same, then I can, and it anyways gets cancelled, therefore 1 is to 1 ratio.
Yes, sir.
Is this clear?
Yes, sir.
Did you take the snapshot?
Yes, sir.
Attempt the 25th question. See, 24th we have already done, right?
Yes, sir.
In 24th we learned how to swim around. So start from somewhere, start running here and there, here and there. The same process will be there for A, B, C. Therefore, all the three are the same. And also we can remove the 5 microcapacitor. I'll explain that again over here. Okay.
There are only the three that I.
In the 25th part
Yes, sir.
or 24th.
In the 24th C bit.
Okay. And that is also the same, right? You start. So
There are like the figure which they give.
first, I know. First, let me discuss the difference between connecting a conducting wire. Okay, connecting a conducting wire and a capacitor. Having same potential difference. Having zero potential difference. Zero potential. See, there is a difference between this. So what we are saying is, in one of the questions earlier, You have a capacitor here, you have a capacitor here, and whatever is the remaining story, of course, we have two more capacitors, but let it be a very big circuit also, it doesn't matter. If I connect it by a conducting wire, if I say this point is P and this point is Q, what is the corona discharge? What is the what is the job of the conducting wire? To make Vp is equal to Vq, right?
Yes, sir.
Here, I am not making Vp is equal to Vq. I am connecting by a conducting wire, and that conducting wire is making Vp is equal to Vq.
But then if the uh, capacitance is same, then only we can get it.
Let the capacitance be different or any story that you want. I have 2 points P and Q on a circuit, and if I connect points P and Q, the potential at P and the potential at Q will be same. Do you know intuitively your brother may use that board, right? Electrical board. Intuitively, you will not attach 2 points in between a circuit by a conducting wire because you know it is going to blast. Do you take a wire and put it in positive and negative? Even in childhood also you will not do that. You will feel some kind of a scary thing will happen.
Already did that.
Yeah, but you will feel some kind of a scary thing will be there, right? By experience, I'm saying. You don't need
Yes.
physics for it. You just your practical experience. Intuitively, you will not do it. Suppose you have that huge electrical wires that go from one place to another place. You will never try it over there. Once you have tried it with your switchboard, 100% you are not going to. It's not like, oh, I've already tested it, it's okay, it's fine, yeah, nothing will happen, go and try. You will not connect 2 points by a conducting wire because you know there is charge flow going to occur by connecting a conducting wire. Correct? By connecting 2 points by a conducting wire, you know that there is a charge flow going to occur through the conducting wire. Why do charges flow?
Because of conductor.
Because of
I mean, potential difference.
because there is potential difference. The charges will flow by attaching a conducting wire. The charges will flow because there is potential. But till when will the charges flow? Because it's a pure conductor that you're connecting. Till the potentials become same.
Yes, sir.
So corona discharge concept was only this, that the any conducting wire, once you connect it, it is going to flow the charges in such a way in an instant of time that the potentials at point P and Q become the same.
Yes, sir.
So the condition here is we are connecting a conducting wire. The result is potentials are same.
Yes, sir.
Here I am connecting a capacitor across zero potential difference. That means where the potentials are already same. So I have some part of the circuit here. I have some part of the circuit here. Now there is 2 wires, just like over here. There are 2 wires going. Take some point P and Q, or let's say take some point R and S. Now capacitor we are connecting between points R and S such that they have zero potential difference. That means in initial statement only I am saying VR is equal to Vs. Potential at point R is same as the potential at point S. Now what am I doing? I am attaching a capacitor.
We have to take that after charges get fully settled.
See, that's why I said what is the remaining story in the circuit is not important for me. Let it be anything.
Yes, sir.
Irrespective of anything, In this situation, initial statement only we are saying that the potentials are same. In that earlier statement, we did not say potentials are same. We said we are connecting by a conductor.
Yes, sir.
Connecting by a conductor results in same potentials, but having same potential then connecting a capacitor is a different story. Two different sequences, two different situations are there.
Yes, sir.
There I am making the potentials to be same. Here I already have the potential to be same, VR and VS, and I have a capacitor in between. Because there is zero potential difference, according to my Q is equal to CV, my Q on the capacitor is 0. That means there is no charge distribution on this capacitor. So if it is alive or dead, it doesn't matter.
Yes, sir.
Now, in the earlier question, question number 9, you connected it by conducting wire, making the potentials same. Therefore, the left capacitors and right capacitors, we took it as parallel.
Yes, sir.
Connecting a conducting wire results in the potentials to be same.
Because in potential, I mean, potential, if
Difference.
potential difference is same, like we take it parallel.
Parallel. It is parallel. We don't take it parallel. It is parallel. It's
Yes.
not like we are doing some corruption over there. It is parallel when the potential, the condition for parallel is potential differences are same. Okay.
Yes, sir.
Now, so in 9th question, we are using the first thing. In 24th question, I'll just draw the A bit first. Okay. In
Yes, sir.
24th question, let us look at the A part. So this applies to my 9th question.
That is fine, sir.
But I'm discussing the effect of what we are trying to figure out.
Yes, sir.
I mean, whatever we discussed here, the first case is applicable in 9th question. But if you look at the 24th question, go up one capacitor, another capacitor, go down one capacitor, another capacitor, and this is a capacitor. Okay.
Yes, sir.
We have 1, 2, 3, 6. 1, 2, 3, 6. Whatever, microfarad story. We are not interested in that. What we are interested in is the ratios. 1:2, 1:2. So why will it matter? Why will it matter is because we said what is terminal meaning? Terminal means
if the ratio is same, it means that like the charge is flowing in.
Correct. What is terminal meaning? Terminal meaning means if plus Q charge is going from left hand side, minus Q charge is coming from right hand side. This is the terminal meaning, right? Terminals. Next point is the division, this plus Q will be divided into Q1 and Q2 on the basis of the capacitances that I have next, ratio of the capacitance.
Yes, sir.
So if I have plus Q1 going here, due to the same ratio over here, my minus Q1 should be going over here.
Yes, sir.
Similarly, if I have plus Q2 going over here, my minus Q2 should be going over here. Clear?
Yes, sir.
Therefore, my minus Q2 is here, my plus Q2 is here.
As it is an insulator.
Minus Q1 here, plus Q1 here. See, till now, I haven't yet implied either of the situations over here.
Yes, sir.
We haven't applied any of the situations over here. We are only discussing something. That's why I told you over here, let the remaining of my circuit have whatever story it has. In this
Yes.
situation, I am starting from VR is equal to V. In this situation, I am starting from VR is equal to V. Let whatever be the story in the rest of the circuit, doesn't matter. What do I mean by that? The rest of the story in this question is telling me that the charge on this capacitor is zero, which is nothing but the potential difference across the capacitor is zero. So VR is equal to VR.
Yes, sir.
Is this?
Yes, sir.
I'm not editing the video, I'm just posting the entire thing just like that. Because I want you to have this part in your thing. Okay?
Yes, sir.
Whenever initially we will always have doubts when you connect two points by a conducting wire, and when you talk of I am removing a resistor, I am removing a short circuit, we use the English, too much English, right? Short circuit, I am short circuiting this. So when that fellow is doing on the board, you feel amazing, but later on when you go home, you'll go crazy. What did he do? Right? So this confusion will prevail for some time till you get used to this thing. The difference between the stories is in the second story, your circuit has a certain way of its arrangements so that the potentials VR is equal to Vs. And in that situation, when there is a capacitor between R and S, that capacitor can be removed because it is useless because Q is zero.
Yes,
Whereas
sir.
in the previous one, you have some story, great, but not because of that story. I am attaching a conductor, therefore my VR is equal to Vs.
Yes, sir.
So in the earlier situation, I am by attaching a conducting wire, the result is VR is Vs. In the second situation, due to some story in that question, due to the arrangement of the rest of the circuit that I have, VR is Vs. In that situation, if I have a capacitor or for a resistor also over there, I can remove that. If there is some capacitor or resistor, I can remove that. It is useless. Is this clear?
Yes, sir.
Now coming to the C part, I'll now I'll explain the 24th question.
I
Okay.
think I understood, sir. Like if we take as an isolated thing,
No,
both will
too
have
much
plus
English,
Q and minus Q.
much physics. So let us go
Yes, sir.
slow. Okay. Now I'll just draw over here. Okay. One fellow and one fellow here and another fellow here. One fellow from here goes and connects over here. Correct. Now
Yes.
what do we have? We have 1 and 2 here, 1, 2 here, and we have 3 and 6 over here,
Yes, sir.
the capacitor here. 3 and 6 over here, and the middle fellow is 5. Now, I don't know all those English terms and all. Try to understand how I'm looking at this situation. I will start naming points. Very important thing in all circuits in current electricity or in capacitors is, or in future also in any circuits, start naming points. I will name this point as A. That basically implies I am saying the potential at that point is VA. But we will not keep saying that again and again.
Yes, sir.
We are mainly referring to the potential only, but we are naming it as A. See, if this is A, what should this called? Should also be called as A only,
Yes, yeah.
because it is connected by a conducting wire.
Parallel.
That way
Yes.
also you can say. It is connected by a conducting wire. There is nothing in between. But next thing, in circuits, it is a good habit to start from somewhere and start running. So I started here and I started running. I found a capacitor. Whenever I
It
find
will be used.
any electrical instrument, that means it is telling me that there is a potential difference.
Yes, sir.
That means From here, wherever I am running till this point, it is always A. But as soon as I cross this bridge, it should become B.
Yes, sir, because some of it will be used.
I don't know. I simply said I have an electrical device in between. It can be capacitor, resistor, inductor, or any term.
Yes, sir.
I don't know. I don't have to know. In this story, I am running. I found a bridge. What type of bridge it is, too much of physics, I don't know. I just know it is a bridge I have to jump, therefore I am writing it is B. Okay?
Yes, sir.
So on and so forth. Keep running. Running, running, running. Everywhere it is B. Jump. C. Okay?
Yes, sir.
Keep running. This is also C. This is also C. Jump. D. Now keep running. Already you named it as B. So there is no point running there. Okay? And also keep running. Jump. Already you've named this as a different A. So my job is done. A, B, C, D. Now everywhere I have named it, named the points, resembling what? Basically potentials. My points which I am naming are resembling my potentials, meaning that if I have any other place where I did not explore, it is better I explore and see if the same potential is there or different potential. This is a
Yes.
smaller fellow, therefore run, 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 run. Keep running, change, running, change, running, change, running, already changed, running, already changed. Oh, job done. Now, he has given me some other figure. I don't know much of physics. All I know is in between 1 and 2, I named it as A. Correct?
Yes, sir.
Let me repeat the same story. Keep running towards 1. Oops, jump. B. Keep running towards 3. Oops, D. Keep running towards 6. Oops, D. Keep running towards O. Already named. Already named. My sequence is the same. Therefore, these two are the same.
Yes, sir.
Are you understanding? I am running through 1, then 3, wait, then 6, then 2. Okay?
Yes, sir.
And as I am naming, I am getting the same situation. My 5 is across between B and D. My 1 is between A and B. My 2 is between A and D. My
Yes,
3
sir.
is between B and C.
Sir,
And my
why can't we
6.
go? Why can't we go around 1, 5,
Why can't we go along?
1, 5 to leaving 3 and 6?
Why am I not taking a right turn from here?
Yes, sir.
Okay, we can do that also. This is A. This is B. Take a right turn. Name it as C. You name him Ram, Lakshman, or you name it Akbar, doesn't matter. Human being.
Yes, sir.
Doesn't matter what you name. You name this as C, then you name that as D.
Yes, sir.
You name it. What's the problem? What am I doing in between these two? I am trying to figure out if the sequence is the same of my running.
Yes, sir.
If the sequence of my running is the same, that means both the circuits are basically the same.
Yes, sir.
Now, here I figured out that Q1, Q2 story, Q1, Q2 story. Same happens here also. Q1, Q2 story, Q1, Q2 story. That means my VB and VD, VB is equal to VD. Therefore, I can remove off my 5 microfarad.
Yes, sir.
For 1-3 series, 2-6 series, just like the previous one. All A, B, C, all three are same in that question. Screenshot.
Yes, sir. The 25th is also same.
25th, we don't know if it is same or not. See, if it is same, why did I run? I ran all the way to check if it is same or not. First, I need to run to know if it is same, right?
Here it isn't same.
Okay, good. You learned running. 25th, do the first A part.
Yes, sir.
Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share, and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.